Okay, worksheet number 3, hypothesis test for the mean. And this time we are not given any direction, meaning we don't know if it's greater than or less than. Okay, so problem number 1. Okay, we are given right here the insurance company, and the life expectancy last year was 77 years. Okay, and so the company or the insurance company has been thinking like maybe it has changed. Okay, so it's just saying change, meaning it's just saying it's different. It doesn't it could be greater than now or less than. Okay, so we are given a set of data here. There are n is equal to 20, and so you kind of know already that the degree of freedom would be n minus 1, so that would be 19. Okay, and we are being asked if we have you should change it. There's an appropriate hypothesis and state your conclusion. Okay, is there evidence that it has changed? Okay, so let's start. And so we have the null here. So the null would be the previous belief. Nothing has changed. It's still 77 years. So we are going to say here okay, the mean life expectancy is 77 years, and then the alternative is, okay, again, we don't know, we don't have any direction, so we are just going to say it has changed. It's not equal to 77 years anymore. Okay, so that's our alternative. The mean life expectancy is not 77 years. It has changed already. Okay, so we go to the model, and again, the model is where we do our assumptions and okay, the 20 sample data were randomly selected. Life expectancy is independent, given that they are randomly selected. Okay, so the 20 sample is less than 10% of all their customers. And number 4, again, this is where we do the work. Let's look at the data. And again, I've already encoded the data, and I'm going to do now the one variable stat. So I'm going to go menu, statistics, stat calculations, one variable stat, hit OK. This would be life expectancy. Okay, so I'm just gonna copy the mean here. The mean is 78, the x bar is 78.6, and then the standard deviation of the sample data is 4.4768. Okay. And then I'm going to look at the histogram of the data. I'm going to go right here, life expectancy. Okay, again, I always want to check if there are outliers, so I go check if there are outliers. I'm going to check the box plot first. Okay, so there are no outliers here, and so I'm going to proceed now with the histogram. I'm gonna look at the histogram. Okay, I'm going to change the bin size of the histogram. Remember, the standard deviation was 4.47, so I'm probably going to do 4. Let me change the plot properties, histogram properties, bin settings, and I'm going to do equal bin, and I'm going to adjust this to 4 and hit OK. Okay, I'm going to zoom out, so I'm going to do zoom data. Okay, so pretty much this is I would just say this is unimodal, and I would just say roughly symmetric. And if you're not comfortable with saying roughly symmetric, you could just say we have a little bit of left skewing and we proceed with caution. But for me, I'm just going to say, because the general shape here, remember, I only have 20 data here. Had this been more, this would have been unimodal and symmetric. Okay, so let me write that. Okay, the sample size is moderate, but the histogram, the data shows unimodal and roughly symmetric. Okay, and so I'm going to write now the final statement of the assumption and condition. Okay, so with conditions met, we assume T model and perform a one sample T test. Okay, part 2 next.